Okay, ELK stack for hackers. So, first of all, who is a hacker? Is she a hacker? Or maybe he? Or this guy who's effectively trying to solve the hacker problem in a unique way, you know? I guess he has 99.99% chance of stopping hackers. But personally, I think that hackers are about connecting the dots. They know how to connect the dots. They know how to think out of the box. And these are the main features of hackers. But first comes first, who am I? I'm a security consultant at Viris. We are a small but lethal company when it comes to breaking in, like penetration testing, social engineering. And I was 3 times at DefCamp. This is a picture from 2013 where Milan Gabor, I don't know if you can see him in the corner, we presented ELK, not ELK stack for hackers, but how to analyze and read application in a dynamically way. Basically, we cheated in games mostly. And Milan should be here instead of me, but sorry, you need to stick with me. But I promise I will give you some valuable information. So, like hackers do, now let's try to connect the dots. First of all, what is ELK stack? It stands for Elasticsearch, Logstash, and Kibana. And ELK stack is usually used for event monitoring. For example, if you have a computer network, you want to know what is happening around the network. But we are using the ELK stack in kind of different way. We use it to put Wi-Fi data into the ELK stack and visualize and see maybe some strange patterns. Because if you know, big data is all about patterns. And I will show you that when I'm talking about Wi-Fi data, I can talk about big data. So this is an image of ELK stack. You can imagine a computer network. You have servers, and their servers are producing a bunch of logs. And on those servers are shippers. These are separated components, and ship their servers to a centralized server with Logstash indexer installed on it. Logstash indexer is a component that does enrich the data and adds some metadata to the data and so on. And after that, this data is transferred to Elasticsearch. What is Elasticsearch? You can say it's a distributed search engine, for example, but it's a lot of more. It's used for storage and also for retrieving data. On top of it is Kibana. Kibana is kind of the query engine that queries the Elasticsearch and displays the data in beautiful graphs. You can have a lot of stuff. I will show you this later. So just few things about big data. According to Wikipedia, information privacy is one of the challenges. And why is that? Let me explain. I read an article about that smart people prefer curly fries. What has curly fries to do with smart people? Actually nothing. I tried to eat it, but it turned out that I'm still dumb as I was before. So, but what they did, they carried out an experiment on Facebook, and based on the likes, for example, if this colleague in the first row is smart, he tends to connect with all other smart people because we like to connect and share ideas with the same people as we are. So after he liked curly fries, it turned out that other friends that are also smart like curly fries. And you can imagine a river flowing, and at the end, it turned out that smart people like curly fries. And what has this to do with information privacy? You see, based on their likes, they can tell or classify you. For example, they can tell if you're a terrorist or if you're gay, straight, I don't know. It just likes. So next time if you like something on Facebook, think twice. As already Snowden pointed out, metadata is actually activity records. And then a guy asked him, how many times you need to retweet Snowden tweets to become on the list on the radar? And he replied that only once. So I did retweet twice, not to become one on the radar. But here's another example of big data. Anybody seen this? This is Watson. He was actually pretty good at Jeopardy. He beat 2 state championships. No, 2 overall champions of Jeopardy. And he was able to recognize natural language. And for the knowledge thing, he had more than 4 terabytes of data, structured and unstructured. Basically the whole Wikipedia. So you can think in terms of big data like there is knowledge behind it. Do you familiar with this screen? This is the output of AeroDump NG. It's the toolset of Aircrack, and it's used mainly in monitoring Wi-Fi data and so on. How many of you use Aircrack NG? Okay, the right audience. But what has to do big data with Wi-Fi? Actually, a lot. Later, I will tell you how to set up the ELK stack for hackers. We did this and did some monitoring in the office. We are in the 10th floor and monitored about 2 weeks. And this is the number of records, 25 millions. So you can talk, when you talk about Wi-Fi, you can talk about big data. Now here's the ELK stack for hackers. You remember those images about the ELK stack? We add the AeroDump NG to this image, and we have the ELK stack for hackers. But I would like to do some hands-on. I would like to show you how to set up this thing. For this purpose, I will go to my Kali Linux machine. I hope you can see it. Here I have an alpha card. I already put it out into monitoring mode, as you can see. And first of all, to capture the data, we had some issues because AeroDump NG output doesn't support JSON. Why JSON? Because Elasticsearch speaks naturally in JSON, and also Logstash knows about JSON. So we decided to modify the code of AeroDump NG and added a method that's called dumpWriteJSON. It's basically a copy of dumpWriteCSV with slightly modifications. So this supports the JSON file format. Also, what we did change is the number of probes. Anybody know what probes are? Okay. For those that don't know what probes are, if you are, for example, connected in your home network and then come to the DefCamp conference and put out your Wi-Fi, your phone or device will ask, hey, is my home network around? And this is actually a probe. And it turns out I can catch those probes and also the name of the Wi-Fi network you have been connected to. And I think the number was 10 in the original version of AeroDump. So we changed it to 1,000 because we found that one client has more than 100 probes. So he has been connected to 100 and more networks. And you can guess that based on this data, we can tell a lot about this client, where he has been moving, where he's been connected, and so on. I will show you this later in practice. But so let me go to the ELK stack. You see here is Elasticsearch running in the foreground because of debugging purposes. I like to have a taste of what's going on. And here is Logstash running. This is a typical message he gets from AeroDump NG. And you can see that he is doing some repackaging of the JSON. So in this kind of way, he's then sending the data to the Elasticsearch instance. And here's Kibana running. Let me show you the config file of, this is the config file of Logstash. It's pretty straightforward and easy. We are reading the data from a file that is located here. We are just seeking for JSON. And after that, we are applying a filter on it and telling Logstash that it's actually JSON and doing some modification. At the end, the outcome is the output to Elasticsearch. And that's basically it. So let's try to run arrow dump ng. Okay, I will find the comment. Here it is. Nothing special about it. I just tell it that the output format is JSON. I would like to have the manufacturer of the client. So based on the MAC address of the client, I can get out the manufacturer. And I would like to list them on channel 1. Let's run this. And you can see the pretty much output of arrow dump ng. Now let's move here into Logstash. And you can see the data is running or is parsing. Now to the final act. This is Kibana. Anybody use Kibana? Great. You can see here the data, and if I'm refresh the stuff, you can see the counter has increased, but nothing much here. I can do, for example, a full text search and grab some data out of it, but the real power behind Kibana are visualization, for example, like this. And if you put all the visualization together, you come to the dashboard. This is an example of a dashboard. It's from today. And it should be changed because data is running live from this Wi-Fi card to here. And you can see you have already a pretty good image what's going around you. So with this basic setup, you get very quickly an idea what's going around. For example, we encountered today 706 clients that have been around walking. And we saw 12 wireless networks around. And also 76 physical access points. The BSSS ID is the abbreviation of the MAC address of the access point. But let me do some filtering. For example, I was also monitoring yesterday. I know I was evil, but let's select yesterday. And see, you can see the data has been changed dynamically just by specifying an other filter. So let's select, for example, DefCamp free network. So actually, oh, not the right one, sorry. This was a probe. I need to add the visualization because I forgot about it. This one, I think. Okay. You know, if you do live demonstration, there is always something not working, or karma is bitch. So let's do this. And for example, not the CTF, I'm interested at DefCamp free. This is the right network. And you can see the graphs have been changed dynamically. You know that the encryption is open. You can see that 121 stations have been connected. There were 31 access points physically yesterday. But this data seems sometimes not accurate because I was moving through the conference and I sure didn't capture all the clients that have been moving around. Let me explain you this simple graph here. From the inside to the outside, you can see it's about the DefCamp free network. And here outside, you can see all the access points listed. And these slices are actually clients that are connected to those access points. And those clients have this vendor. So it means I can just, by simple this graph, I can get a lot of information what's going around. So from the network to the client to his manufacturer. And based on this data, I can tell you, for example, that people at DefCamp like Apple more than they like Samsung. I can also tell you that here are hackers around because they use their laptops. They are not just with Samsung devices or also Apple devices. I can tell you that DefCamp is relying on Cisco as the main manufacturer. And also here I can see the activity of the clients. How many clients have been connected at which time? You remember I said that this data is not accurate because I moved. If I did the monitoring stationary, this would be more accurate. But now the funny part, or let's say the evil part about probes. For example, I can see the probes of this guy or girl. And what I can tell about these probes, actually a lot. If you recognize yourself, just raise your hand, please. Okay. VP studenti, probably a student or a professor. VP of Doom, Pony Express. I guess this is the phone of Jason Street because he works at Pony Express company. So let's see on what's here. But you get a point. Before, there was a presentation about how they choose the VPA2 passwords, and it's based on their SSS ID. If I'm correct, I'm correct. So they came up with an idea that they named the Wi-Fi access point uniquely. This is actually okay. It doesn't tell you much about a person. But the bad thing is, if someone has been monitoring you and you have a unique access point and he is doing, like for example, using, just a minute, this kind of thing. This is iSniff, a tool to locate the location of a wireless network. It uses Wiggle services to, based on the SSS ID, which is the wireless network name, to get a location. And for example, this name maps to Romania. And so basically, based on your probe, I could tell where you're home. It's not that funny anymore. Because this stuff can be used for stalking. And I also do a lot of, let's say, penetration testing and social engineering. And you know, in the face of information gathering, you go to Facebook, you go to LinkedIn, and based on these probes, I can also tell you a lot about you. If you like tennis, if you like to go to the restaurant, which kind of restaurant, where is it located, where you have been there, and so on. So basically scary, but a lot of funny things can be seen here. And this is an example of big data, you know. Let's see, again, if I have here something interesting. Let's remove this and search for iPhone. So I'm interested in the probes, and let's see, For example, not this. It's kind of hard to work on this desk. Ganescu's iPhone. Yeah. I hope this is not his surname or first name. What I mean by that, iPhones are usually configured, at least at the beginning, that they send out probes about the owner of the iPhone, and yeah, it's his iPhone. And so I know he has an iPhone, he has birth office 3, maybe an office that he is working in. Let's try to find out if this is actually on place in Romania. Yeah, it actually is. So maybe an office, he's working there, he has an iPhone, and so on. So you got an idea. Based on the probes, I can tell much about a person. I can classify it, and I can find patterns into it. So I would like to show you something else, because we still have a lot of time. How do you know if ELK stack is running? Basically, simply, just let me find the comment. You can do a curl search like this. My Elasticsearch instance is listening on localhost. And it's listening on this port, 9200, as you see. And what's the strange thing about Elasticsearch is that it doesn't have any security access control into it. Of course, you can pay for an additional component like Shield, for example, and then you have access control. But the only security feature in terms of access is that it's running on localhost, so you cannot connect to my Elasticsearch instance, for example. But as it turns out, people always find ways to do it the wrong thing. For example, how many of you use Shodan? Do you know about Shodan? Okay, a few. Here is a search. It's in Romania, and I just searched the Elasticsearch string. And you can see that 30 instances of Elasticsearch are wide open. What that means, I can basically query those databases. I can basically delete the indexes or the data, and you got the picture. I would like to show you something out of the topic. Maybe I search for MongoDB here. This is even nicer. You can see that Shodan shows you how big is the database. So even a nicer interface, for example. What I mean by this, if the vendor doesn't do it right, there will always be people that also do it right. So, okay. Let's move on. I have still time, and maybe not so many. So if you're bored, sorry, only 20 minutes left. Okay. Elasticsearch. I told you that is based on JSON. It's document-oriented. And it's scalable. It's kind of distributed database. And Elasticsearch is also, in his basic terms, a hacker, because every technology was around, and they just connected the dots. Distributed databases was around, full text search was around, and what they did is bind everything together and make it more easier and efficient to use. And this is why Elasticsearch is also a hacker, you know. I showed you already this image. Yeah, and this is the power of Kibana, the visualization. You can look at the airdump ng output, you know. I also prefer console outputs like CMD, I don't know, bash. This is the hacker's kind of way. But you know, visualization are beautiful. You can discover quicker patterns into the visualization and so on. So what Kibana actually does is all the heavy querying here, but just you do a few clicks and Kibana sends you this data to Elasticsearch and then it comes out this beautiful visualization, which looks kind of blurry in this, but never mind. Okay, Logstash, I don't know if you see it, anything, yeah. I told you already about this. This is the scary part. And you can see that we can map probes location. This is actually where we did 2 years ago all the presentations. Now let's try to construct a graph in Kibana. Do you think it's hard? Any ideas? Nobody? Okay, I will show you. Let's put a new visualization and select pie chart, new search, and here I will select, I will here select unique count, for example, and let's say ESSID raw. Okay, this is not working yet. Okay. Now again, I will select the terms and I will select SSID raw. This means actually I'm splitting and seeing what wireless networks are around. I limited this kind of visualization to 5 pieces. Let's do 10, for example, and I can see already what's going around, you know. Let's add another sub-bucket, and let's do another aggregation, and let's say BSS ID raw. What this means are the MAC addresses of physical access points. And you can see here clearly how many access points does a network has. And if I'm adding another sub-bucket, like this, and selecting stations MAC raw, I can see already which clients are connected to which access points and which access points are parts of one network. So basically just by doing few clicks, I get a lot of information. If you put this information into a dashboard, you have then real power. What I forgot to set you is that we actually did upload to GitHub on patch of airdump ng. It's available for free. You can patch your aircrack instance source code, and you have JSON support. Some basic information is available here, but it's not so hard to do this stuff. So, how many minutes still? Okay. If you know about SQL injection, this is not going to happen. No, I'm just kidding. I like to share ideas because this is all about the conferences, to share and get knowledge, if you know what I mean. Where this setup can be used. For example, of course, in penetration testing, social engineering, and security audits. This is the first kind of thing you think about it. Also, we can use it as a CM for Wi-Fi, for example. What a CM is, you maybe know. For example, if I have a small device that is capturing and putting data into ELK stack, and I lock it for example, to 5 MAC addresses that are connected to my network, and suddenly 10 MAC addresses are connected, you know then that something terrible has been happening. So this kind of stuff you can do with it. Of course, evil intelligence gathering. This kind of example I showed you based on the probes. And you know, if you have a lot of data, if you're monitoring everybody around, you can see patterns into the data, match people, do something out of it, and so on. War stalking, for example, if you're this kind of person, I'm not. And I also read about an article. Policemen had a great idea about tracking stolen phones. Because the only condition, you need to know the MAC address of the phone. So if you need the MAC address and you do the monitoring stuff, you know that somewhere around is a stolen phone. But if you do triangulation, for example, you can pretty much show the person who has a stolen phone, not here in this crowd, but maybe on the street. So this is another idea where you can set up or use the setup. I've talked to you about it. And also, if I'm adding traffic records of open networks, you know, open networks like DefCamp 3 are not encrypted. So this means I can sniff the network and I can capture maybe some your browsing data. And if I'm adding to all this data that I have, also where you have been browsing and when, then it becomes scary. So, but you know, with great power comes great responsibility, and you should use it as you wish. I'm just going for my back. Can you give me my back? There. I forgot to bring it here. Thank you. I would like to show you one more thing, and then I'm done. Here it is. This is an TP-Link router. It's actually small. It consumes pretty minimum, like say, power. And if I put it in the battery, I have my private monitoring. I've just X-routed the router and put OpenWRT on it. It's on an USB device. And also I did some init scripts. So if I'm just adding the battery to it, Aircrack automatically loads. And by now you should switch off your wireless because I'm monitoring you. And after I'm done, I'm just putting out this USB and putting all the data that I have into my ELK stack and visualizing and searching patterns and so on. So it's pretty easy to set up things like this. And with OpenWRT, you can most surely do it. So this is what I had in mind. Are there any questions? Yeah? Please.
Did you think, or do you have already scripts for looking for phones that were connecting from particular location? For example, can you find quickly my phone that was connecting usually in Poland? Can you do this, or this was not in scope because it needed interaction with the website?
First of all, if you have been connected to a network and you didn't delete this network.
Yes, of course. It is constantly asking for it, and you can search it. And I'm sure that you have it already in your database. And the question is if you can search per country.
Not actually per country because I don't have this data, but maybe if you tell me your network.
You can look for strings with UPC, of course. This was about my talk, yes. At the morning.
UPC? UPC, you said.
UPC, this is the beginning, this is prefix.
Just a second. Like this?
Yes.
Okay, let's try. Okay, UPC v3 maybe?
No, the particular number. This is, you know.
Okay. Not here. Not here.
Because this is a string, you don't have space. This is only a prefix for it.
Okay, maybe I didn't catch you. But as you know, Elasticsearch supports full text search. Maybe,
No.
maybe like this. Do you have, what for a phone do you have? Which manufacturer?
Samsung, of course.
Samsung. No, sorry. I didn't capture you.
Okay, but I was talking with you when you were sniffing with my phone on.
Yeah, but maybe this, you know, there's some errors into it, you know.
Okay, okay.
So, but you get an idea. I can catch every phone, but I just put some of the data that I get into the database, and then I go to do the analysis and so on.
Okay, that's all from me.
Any questions? Don't be shy. There's some question. I will try to answer.
When you search in Kibana and you receive these results, can you export the results?
Yeah, the results are in Elasticsearch. You can
Yeah,
export.
I know they are in Elasticsearch, but if you want, for example, you want to filter some kind of like result, like just have like 50 hits or something. I didn't see how you can export them. I mean, it's possible. This is my question about Kibana is basically.
Yeah, I think you can export it here, I think, but I didn't go into it because I didn't need it. So basically, I think you can export into comma-separated files and everything else. But
you can from API, but I mean from interface I didn't see. Anyway,
but it's easier to do a search on Elasticsearch and export the data in this kind of way. For me. Any question there, guy?
Hi.
Hi.
As you know, many of the routers we have some kind of backdoors.
Yeah.
Do you think that the engineering, I don't know, the engineers who did them or like the factories did that intentionally? And do you think that they take some kind of data from that and build some kind of database?
Do you mean regarding
if it's coordinated or is just like for telecom purposes for updating a firmware?
But you mean the probes thing or something else?
Well, I mean 30–40% of the routers that have backdoors. That's what I mean.
I don't know. Maybe some, maybe not. I'm not expert in, let's say, state affairs.
All right, so the next question, do you think that someone did until now like a bigger database of this data, gathering from all around the world data?
I've never heard of it, but I think they did.
I think that too. Thank you.
Yeah. No question more? You can catch me later if you want. I'm here till tomorrow, so we can grab a beer or something and have a nice conversation. No question? So thank you.